Another algebra question here, this time a mite tricky. We want to prove algebraically, using letters, that the difference between the squares of any two consecutive integers, so we've got squares and consecutive integers, is equal to the sum of these two integers. Okay, so let's start off with consecutive. Okay, consecutive means comes one after another, so consecutive numbers could be like 6 and 7 because they're right next to each other. I want to do this algebraically, so I'm dealing more generally than that, so I'm going to say that my first number is n and that my second number is n plus 1. Two consecutive numbers that are only different by 1. I'm then thinking about the difference between their squares, so I'm interested now in the difference between n plus 1 squared and n squared. The difference between, so subtract. If I expand this bracket, I get n squared plus 2n plus 1. Subtract n squared, and that gives me 2n plus 1. Well, let's go through to the answer. We're asked to show that this is equal to the sum of these two integers, is equal to the sum of these two integers, n plus 1. Well, that does make us 2n plus 1. So that's exactly what we've got here. So this 2n plus 1 could be written as n plus 1. And there we have algebraic proof that the difference of any two consecutive numbers when squared is just equal to the sum of those numbers.